So we're going to review some renderers using V-Ray and Manta Ray. But as you know, as you experienced last week, Manta Ray has amount of presets, very easy to use interface compared to V-Ray. So I like to show you some V-Ray interfaces in the lecture, and we're going to move on to the V-Ray actual lab exercises at kind of the last lab exercises on top of SketchUp, and then going to move to the 3D Max and Manta Ray. Also, we can use V-Ray plugin on top of 3D Max later, okay? So for the lab exercise today, some series of V-Ray SketchUp as a review, and we're gonna check some 3D Max environment as well as V-Ray plugin. But actually yesterday we installed V-Ray, hopefully, but if need, we need to install V-Ray plugin for 3D Max. Anyway, I'm gonna show you as a demo, but actually in the lab exercise mandatory submission for today, you need to submit those series of files for today's lab exercise. They are not mandatory. You are very good at V-Ray and SketchUp, I think. So I'm gonna ask you to submit mandatory submission for 3D Max and Manta Ray files, okay? Again, some technical notes, but I don't think we don't need to put an emphasis again on this part. But anyway, our course website already, today's lecture slide already saved, stored, and you can take a look the slide wherever you are. But now you are opening the PowerPoint slide for the lecture, and we use our local area network for sharing files. Today's folder has 180 megabytes for entire lab exercise files. And your student name folder. Your submission should be placed under your name folder. Just please make sure that your files saved in this 504-main computer, okay? And some regulations, I put red fonts like this. And we have accessed Autodesk student community for downloading files and getting the serial numbers, CD keys for your new software, okay, including AutoCAD, 3D Max, Revit, and so on. So most of our major applications we're going to use in this semester all available in this community. So you need to access and get the keys and the downloading files. But actually files already downloaded and stored in this 504-main computer. You don't need to download several gigabytes installation files. This is that student download website, as you know. So if you are not that good at using this website, please sign in the website, okay? Some more regulations. Okay, I believe anyone in this room for this lecture has no problem for these things, okay? Also communication for the course. Okay, let's move to the surface-based 3D modeling and visualization. But before getting started, just for your information, I like to let you know under the course website, you can find out your lecture room, and let me open our class folder, okay? In our class folder, under the lecture, you can find out the video files, okay? This video file from the last week. So you can review this lecture content through this website, Hanyang Portal, or Howl website, Hanyang University OCW, or even from YouTube, okay? So your class all recorded, and also other classes, okay, the same. This one also recorded now. Anyway, even in Hanyang University channel in YouTube, you can find out any of my class. Intro to Digital Design you took last year, or even next year class next semester, next after next, digital design 1, digital design 2, even design computing classes for fourth year grade student or graduate students course, you can watch. But based upon my experience, no one interested in this kind of lecture. I'd like to tell you, just keep your eyes open, just in the real actual, okay? Like today, that's the most important thing. You don't need to review, or you don't need to proactively watch the lectures, something like that. Just take a look at my course material and try to figure out what's going on in my lecture. That's it, I think. Okay, surface-based 3D modeling and visualization. That's the first topic for today. Surface-based 3D model, in other words, sort of polygon-based, okay? You are very good at using SketchUp, I think. And now we are handling 3D Max design. They are all under that category, surface-based 3D model, okay? Surface-based 3D model. As you know, this well-known one single slide overview of the history of computer-aided design. It's same to the history of understanding what is design. That's my sort of definition. This one kind of early phase of computer-aided design, and this is kind of state-of-art, cutting-edge level of development in CAD history, computer-aided design. So let's quickly review. At first, people believed 2D drafting images, front view, top view, left view, right view, such kind of 2D precisely drawn drawings were designed at the time. So computer-aided design also had focuses on representing such draftings, okay, such drawings. But people believe that if we can define objects in 3D XYZ Cartesian coordinate system, even in computers, it'll be very nice, simply because we can rotate, we can just change our view to top, left, right, and so on. And then we can automatically generate any type of views, any type of drawings without any ambiguity, without any problems, okay? That is surface-based, very early phase of 3D modeling. But actually, even if I'm saying it's early developments in 3D modeling, I don't mean that this is not gonna used nowadays. This is really powerful in visualization. In other words, very useful for gaming. So almost entire game engines, game graphics still use this surface-based 3D, okay? Next phase, solid model. Take a look at our real environment. There is no surface. Surface means it has zero thickness, okay? No thickness. But in reality, there is no such object, okay? Every single tiny, thin object has its own material, its thickness, and solid field. Our walls, this kind of walls or columns, any of our surrounding building elements have certain type of solid field, concrete material, wood material, plastic, whatever, okay? That is so-called solid, but computationally, it's a little bit different than I said. But anyway, thanks to solid-based 3D definition, we can make some Boolean operations. What I mean is plus, minus, intersection, union, operations without any problems, geometric problems. And we put some parameters in order to control this object using height, width, depth. In reality, no one says it's XYZ coordinate point when we are designing walls, designing columns, designing chairs. No one says my XYZ point for this arm is this something like that, okay? We say just height with the steps or thickness, something like that kind of parameters. So they can be defined in this way, some human-oriented way. And the most advanced one is based upon geometric shape, geometric definition. We can put amount of design, products, and construction-related information, so-called information modeling. And our subject is building. That is why building information modeling, BIM, is the most important and advanced one in this history, anyway. So now we are dealing with 3D Max design, still in surface-based 3D object. That is why this course emphasized the term visualization, okay? You are in charge of visualize your design in your brain in this kind of computational way. This semester we're gonna deal with some type of architectural drawing, photorealistic drawing, photorealistic rendering, photorealistic animations, or very architecturally generated hybrid representation, graphics, and so on, okay? So this is our main subject, surface-based model. So this is an example of surface-based 3D model. So-called mesh, this kind of spider web-like objects, we don't need to render considering entire structure. We can render from top to bottom, okay? One line by one line, we can render it, surface-based model, and which means it's very good for real-time computer graphics. What is the representative real-time computer graphics? That's game, okay? Real-time rendering. Real-time rendering is very critical for computer game environment. If it's not good speed, your game will be very slow, lag, okay? Anyway, this is surface-based 3D model, polygons, segments, and so on. So SketchUp and 3D Max, Rhino, or any type of 3D surface-based modelers are in this mechanism. Simply, surface models have hollow inside, okay? The thickness of this surface is 0, okay? It's 0. But this is an example of solid model. But sometimes you find out this kind of surface model, even if you cut the model, you find out it has this kind of solid fill looking object. But it's a kind of utility to generate automatic generation of this surface, okay? Whenever you cut, computer can generate auto surface. It doesn't mean that it is solid model, okay? Still, it's just surface-based model. So anyway, my point here is SketchUp 3D Max models, the tools for mostly for visualization, they are still in surface-based 3D modeling tool, not solid, okay? So the components, the sub-geometric component of surface model, of course, are faces, edges, and vertices, okay? Two vertices generate one single edge. At least 3 edges can generate one face, okay? And their combination, face combination, will generate this kind of 3D shape, okay? So we have faces, edges, and in SketchUp interface, we mostly control edge or face. If you pull the face, you can control the thickness or height. If you control this edge, you can change the shape. But actually, there is no way to control vertices in original SketchUp interface. But in 3D Max, you can control everything. The interface named editable poly. Editable poly means you can edit polygons. If you can edit polygons, that means you can control vertices, edges, faces, anything else, anything under the definition of polygon. That's the way of controlling geometry in 3D Max, okay? So here I want to tell you this fundamental mechanism again simply. I like to tell you again some sub-geometry components of surface-based model. Okay, simply think about this is XYZ Cartesian coordinate system, okay? If there is a vertex, just one point, okay, one vertex which has XYZ Cartesian coordinate system. If there is another vertex, we can make a line. This line, so-called topologically, we say this is edge, okay? And another one. And then we can create three edges. Now we have one face, okay? So subcomponent of surface-based 3D, the most fundamental component is something like this, okay? Three vertices based one polygon or one segment, one mesh, whatever it is. This is one single component in 2D, okay? Sometimes we draw some objects like this kind of meshes in rectangle shaped mesh for representing some 3D objects like this. But actually, this kind of rectangle shapes can be subdivided by this kind of triangular polygons, right? Why triangular shaped polygon? This is 3D world, okay? 3D Cartesian coordinate system. If there is another point, and if we represent in this kind of rectangle shape, we can make at least, we should make at least two planes. In other words, 4 points, 4 vertices here can be placed in different plane in 2D. But if this is only 3 vertex based plane, I mean this plane always 2D, okay? One single plane can contain 3 points without any problem. But if we have 4 different vertices in 3D Cartesian coordinate system, it's not possible. All those 4 vertices are placed in single plane, okay? Mathematically. Sometimes it's possible, but we say it's almost not possible. So for this one, we have one single plane, okay? And for this one, we have another plane. Plane means exactly 2D defined. This is X, Y, and we can represent 3 points in just 2D, okay? 2-dimensional way using X, Y. This plane also has X dash, Y dash 2D plane in order to represent 3 points without any problem in 2D. So series of 2D planes for one single object can be represented without any problem. This kind of approach is so-called surface-based definition of model, okay? So let's take a look this rectangle shape. In SketchUp, if you didn't put any options and if you draw a circle, it has 10 or 12 segments. In other words, if you zoom in, you can find out this kind of series of lines, okay? If you put more segments, you remember last week for the T part, if you put more segment numbers, that T part is looking very soft, curved, but more lines, more definitions. In other words, bigger weight, file size, okay? Anyway, still they are straight lines, collection of straight lines. It's a curve. How about 3D surface? Take a look. Some triangular or even rectangular shaped object, but they are the sequence, the collection of straight lines and straight defined objects. So if you remove some unnecessary or some intended removal from this object, you can find out hollow inside, just surface definition. But anyway, they are just collection of straight lines. Take a look, this very curvy 3D surface. Even if it's looking 3D, in terms of segment meshes, node definition, take a look, all are triangular shape, which means one triangle segment mesh has one 2D plane. Amount of 2D planes for defining 3 vertices and their connections. One is face and collection of face going to make this sort of organic shaped surface. Okay, this is fundamental way of defining 3D object. Okay, so we have this kind of geometry. Okay, we have sequence of geometric definition of surface-based model. So this box is still surface, but we are talking about visualization. What is texture map? What is drawing? Okay, let's take a look this box, gray box. What if we want to change the color of this one to yellow? Simply we can place yellow colored image on top of this surface. Okay, another surface layered on this surface. What if we put this stamp-like image file? Simply attach it, and you can see, you can visualize this box has this stamp attached on this box. Okay, this is so-called texture map. Okay, so in terms of texture map, there are several different ways. You can control the size of this stamp image, or you can fill in this surface with amount of stems, okay, the same stems. So this surface can be texture mapped, so-called texture map. This is simple and easiest way of visualization for this kind of 3D visualization. This is something about rendering, okay? Formerly, I told you something about geometric modeling using some SketchUp-like interface. And this one simply shows you what is texture map. Texture map is really convenient and easy way of creation for 3D visualization, especially realistic visualization, something like this. Computationally, even if it has some round corner or some complicated geometry, this 2D texture can be totally mapped, dropped over any type of 3D shape, okay, 3D object. Simply, this is surface-based model. So it is one of the easiest way of 3D modeling and rendering, okay? Surface-based model is really fast, easy for generating 3D geometry and 3D visualization, okay? So in this semester, in this course, we are dealing with surface-based 3D because our current top priority is kind of 3D visualization. So by using SketchUp and V-Ray renderer interface, the terminology or some keywords from renderer, they are all same. Even in podium renderer, V-Ray renderer, mental ray renderer, they are all same eventually. So that is why I just want to show you some series of slides using some screenshots from V-Ray and SketchUp. We already have experiences on using that, okay? So let's take a look some series of slides as a review, okay? There are amount of free tutorials how to use V-Ray, Podium, Mental Ray, 3D Max, SketchUp, and so on. You can take advantages of that. So as we studied, as we reviewed last week, and even last year when you were freshman, SketchUp is kind of very easy to use application. That is why I installed V-Ray for quick visualization of your design. Okay, so example from V-Ray renderer, it's really photorealistic. Simply this kind of renderer nowadays, V-Ray, Mental Ray, Podium, whatever, Brazil, they are all global illumination based. Ray tracing. Ray tracing is the most important feature of photorealistic rendering. Okay, rays can be traced in order to make any type of shadow casting, reflection, refraction, and so on. Okay, so it's V-Ray, and also in terms of geometric shape, acquiring geometries. We in today's lab exercise, we're gonna use this one too. 3D warehouse, mostly SketchUp file, but in today's lab exercise, in 3D Max design interface, you can directly import any of SketchUp model without any problem. Sometimes you fail to import SketchUp model, but most of kind of old version, legacy version of SketchUp models are importable without any problem with their own texture. Okay, if SketchUp model has texture map, they all automatically converted into 3D Max file, so that you can reuse any of models, predefined models, geometry in 3D Max environment. Okay, using Mental Ray. Anyway, some plugins, location, and so on. Okay, let's move to renderer again. As we discussed last week, I told you we have three main components: lighting source and camera, the views. They are sort of fundamental. We have default light, default camera. Without them, we cannot see anything. Okay, main subject for our rendering, our visualization is of course our target objects. Under target objects, diffuse, reflection, refraction, caustics, or even special effects, they are all something about rendering, visualization. But one set of those terms, intensity, texture map, shadow casting, or even other special features, under diffuse, they are also under reflection, also under refraction. Okay, that's what you saw in actual V-Ray interface, something like this. Okay, the structure. So if you don't know what is texture map, what is shadow casting, how to control intensity, how to control amount of power of lighting or diffuse color, whatever. If you don't know this part, you cannot control other parts too. Okay, for reflection, it has texture map too. Okay, your texture map can be seen under diffuse control, but you can control reflection by using your own image map, texture map. Okay, so that is why I put this some hierarchical structure in terms of rendering. Even if I used terminology in V-Ray, it's also totally same to Mental Ray or any other renderers. Today's lab exercise, I'm going to show you some Mental Ray interface regarding this one. Again, let's briefly take a look some details about it using V-Ray interface. But this is V-Ray interface, but in lab exercise, I'm going to show you Mental Ray interface. They are looking different, but you can find out those same keywords. Okay, what is diffuse? Diffuse is just simply shown your surface. Okay, if you change diffuse color, the object color is going to be changed. Texture map for diffuse, that's what you see on your object, on your design. Also, it has transparency, okay? Transparency control, or even this kind of complicated control, such as BRDF, bidirectional reflectance distribution function. This is totally something about physics. But thanks to this kind of mathematical definition and physics, computers can calculate precisely the same as our real world, okay? That is why this kind of renderer can generate very photorealistic render output images, okay? Next one, under reflection control, reflection rate. In V-Ray interface, it has white color or black color interface. If you put white color, it's totally reflective. But if it's black, it's not reflective, okay? No reflection. But in mental ray, you should put the numbers. For example, 1 means 100% reflective, 0 means nothing reflective. If you put 0.5, 50% reflective, okay? That's the control. But the same, different interface. Glossiness also critical. If you change the number, something like this, 1 is really high glossy, 0, if it's close to 0, kind of looking matte, not that glossy, okay? This is 0.6. The same as in mental ray or other renderers, you can find out this term, glossiness, and also you can control that one, okay? Under the refraction option, you can find out IOR, the most important thing. Default glass IOR is 1.5. Water, something different. Diamond, very different, okay? And also color multiplier, and so on. So refraction IOR based different views using this example, and fog multiplier can change your visualization like this way. So you can refer to this kind of common instruction for controlling this kind of render options. Another interesting thing is this is kind of specialized special effect. The term emissive is V-Ray interface term, okay? But in mental ray, there is special effect and the term self-illumination, okay? I think self-illumination is much straightforward, okay? Simply, if you control this emissive, color and intensity, you know how to control this emissive so that this one is brightly, it's looking like kind of lighting object, okay? So in V-Ray interface, it's emissive, but in mental ray, that is going to be self-illumination and some different style of controlling intensity. Anyway, some SketchUp and V-Ray render tips also placed in this slide regarding what we have experienced in V-Ray and SketchUp. For better texture map, the best option for texture map image is actually PNG file, okay? JPG file is most common file format in our render in 2D bitmap image formats. But the problem of JPG is there is no way to make this, you know what is this, okay? Rectangle shape, gray, white. This pattern means transparent, okay? Void background, void color. Take a look, the windows. Windows are void, okay? This kind of image can be created only in Photoshop or PNG file, okay? If you make this kind of background cut image and save in PNG, this one can be used as a source of texture map. If you use this texture map, this shape can be placed somewhere here without any problem. No white color background, okay? Also, you can put some percentage, okay? If you put 50% transparent on this background, it's going to be 50% transparent. But it should be in PNG file format, okay? PNG file format is very strong. It has full color and transparent background. But its file size is still low, not that big. That is why PNG is sort of recommended file format in this type of rendering. Also, JPG file, sorry, not JPG, GIF file is another famous and common file, especially for web. It supports this kind of transparent background, but the problem of GIF is it can represent only 256 colors, okay? No true colors, no millions of colors available in GIF format. That's the difference, okay? In SketchUp, you know the texture mapping options, such as controlling texture in this mode. So your SketchUp model is Surface 3D. On top of that, if you attach any type of texture, you can control its position, size, or some projection method, or some diagonal shaped map, and so on, okay? Simply because it's surface-based 3D and texture-based map on that 3D model. Also, there are some detailed advanced features in texture map when you are working with surface-based model. One example is this kind of bump map, okay? Bump map will make your visualization much realistic. For example, this one is just texture map, okay? Texture mapped. And this one also bump mapped. Or even displacement map. We're gonna deal with this one in lab exercise later, not today. And in the lecture hour, this is just overview, okay? If you put bump map or displacement, your visualization is going to be much realistic. Okay, this is my picture. I took this picture in some place. And if you change that onto in black and white in Photoshop, and you save this one is really good for bump or displacement source, okay? White part going to be extruded, black part is not, okay? So your geometry can be controlled in this way. So this is bump map file, this is texture map file, okay? If you put this one as a texture map, you can see this one on your surface-based 3D model. But if you place this one as a bump map, your geometry, your surface-based 3D model is going to be looking much realistic. This is V-Ray interface. How about in mental ray? Okay, you can control any of these maps, bump map, displacement map, or any type of specialized maps. But in mental ray, there is very powerful materials, Autodesk materials. On the Autodesk material, if you simply assign bricks, something like these bricks, you don't need to think about bump or displace. Autodesk material presets already has amount of bump maps, displacement maps, and even advanced maps as a preset. You don't need to do anything. They are all has this kind of realistic structure without any your additional control, okay? They all have default displacement or auto-loaded bump map and so on. And texture map, high quality images. That is so-called predefined texture map. We say that presets, okay? Presets defined by experts in material, in Autodesk material. That is why we can take advantages of such easy to use rendering environment. Okay. This is actually an extra one, dynamic SketchUp component. When you open SketchUp, there is a woman or a man standing at the middle of your plane. It looks always you, the camera, simply because that is kind of dynamic object checked always face camera. So take a look this example. I took this picture in the classroom, a student. In Photoshop, remove background and make them transparent and save this file into PNG format. And there is one single plane and simply map this texture. And then this one can be seen like this one, okay? Transparent background. Just one example for fun, okay? We reviewed this one actually before. Okay, let's have a break and move on to the rest of lecture. And we're gonna quickly move on to today's lab exercise, okay? So have a nap. We are now going to review some renderers, okay? In a comparison between V-Ray and mental ray, okay? So-called MR, mental ray. So let's take a look, some pros and cons. Sometimes people believe the V-Ray has very fast ray trace. In other words, simply it has very comparatively fast render speed. That's the pros of V-Ray. But sometimes some bad shader support and so on. These are some general comparison between V-Ray and mental ray. The pros of mental ray is it's embedded in 3D Max design. You don't need to install mental ray plugin or something else. And the most powerful thing when you are using mental ray in 3D Max is amount of presets, Arc design material, pro materials, but nowadays we say just Autodesk material, hundreds, thousands of high quality material available, okay, when you are using mental ray. And or Brazil or Podium or even any other type of renderers, they all have pros and cons, but mostly commercial. Some are free. But anyway, in my point of view, V-Ray has its own style, okay? Certain type of V-Ray style visualization. And mental ray has a slightly different effect, slightly different style of visualization. I think that's the distinguishing part, not the speed or material. Of course, material is very distinguishing feature of mental ray. You can take advantages of very well-defined material, but at the end, if you use your own material, you have to take pictures by your high-resolution camera, and you have to load that as your texture map and control reflection, self-illumination, refraction, bump map, some special features of the renderer, texture map, and so on. At the end, for cutting-edge, state-of-art rendering, you need to control anyway by manual. But anyway, in general, mental ray with Autodesk material provides you very comparatively high-quality render output. Very easy to use, but powerful. That's the main pros of mental ray. But V-Ray has very soft and smooth effect of kind of V-Ray style. Some people love that feature, so you can make very soft and easily smoothed visualization when you are using V-Ray. So this is kind of professionals output example of V-Ray on the V-Ray gallery. Kind of some bright and soft V-Ray render style example. And this one, mental ray example. Some Hollywood movies, mostly they use mental ray or some similar renderer from NVIDIA, some movies, for very well-known movies, movie characters, some animation characters, they basically generated by mental ray renderers, okay? So let's take a look mental ray, or slightly more details in 3D Max design. Distinguishing feature is amount of presets, okay, material related. For example, this is standard material in 3D Max. What I mean is standard material means kind of legacy material type defined in 3D Max. This is its own interface. We have really many tutorials, but nowadays we don't need to use this kind of standard material. Default is Arc and Design material. That is why you need to install 3D Max design, not just 3D Max. If you install 3D Max, you cannot find out Arc and Design preloaded in material editor, okay? This is architecture plus design. Mental ray material is sort of default material. But even in this interface, you can find out diffuse, okay? Diffuse level, roughness, color. If you change the color from gray default to red, your material color going to be changed red. But take a look. This is default Arc and Design material. You can see highlighted, reflective, which means this one has default reflection. If you wanna, this one is not reflective, you must change reflection rate, okay? Default is reflective, highlighted, kind of high glossy gray color material. That is Arc and Design material. I think that's kind of gray colored ceramic, something like that, okay? Anyway, this is Arc and Design material, but if you click this one and if you open Material Navigator, you can find out hundreds of Autodesk material. So here is an example of Autodesk material. This one, the same geometry, okay, stamp like same geometry in this wood box. Take a look this one. It looks like chrome, which reflects with very high glossy surface. This one kind of half glossy, okay, in that kind of different color. And take a look this one. This one looks like really heavy weight solid glass, but this one looks like very thin glass, simply because Autodesk material on the glass there is thin geometry glass and sort of solid glass. So even they are glass material, but they are different looking, okay? Take a look this tile or some masonry bricks looking object. Between the components, it has auto-loaded bump map, displacement map. That is why you can see the surface has some extruded, okay? Thanks to that kind of preset, bump map or any other specialized maps. So in 2006, Autodesk implemented this type of material, Arc and Design, and it's embedded in 3D Max. It's really easy to use, but flexible, okay? And it provides lots of templates. So you can simply navigate material editor, material browser, and simply load that material to your workplace. And physically accurate, okay? And glossy performance, tweakable BRDF, transparency, and it supports some mental ray specific distinguishing features such as round corners. Okay, if you make your rectangle shape, in other words, very sharp corner component, but in reality, even if it's rectangle shape, solid cube, its corner cannot be exactly 90 degree. Slightly rounded, right? That's a real object. But if you make that geometry in that simple definition, if you check round corners and then that corners automatically round shaped in your rendering, okay? That's one of the advanced features defined in mental ray. And some more, some illumination control, indirect illumination control or built-in ambient occlusion. If you check ambient occlusion, emphasized object render shaders looking much better, much realistic. Anyway, several good things in predefined in mental ray and Autodesk material. Of course, mental ray traced, okay, for generating photorealistic rendering, as well as given high quality material. You can make easily photorealistic render scenes. This is kind of given geometry, very complicated meshes. Take a look, the surface meshes. This is so-called Stanford Dragon geometry, which has complicated surface, but take a look, surface, entirely rectangle shaped polygons, okay? So in this polygon, you can simply put Autodesk material and render it through mental ray. This is kind of default color, no material assigned. But if you assign certain varnished wood, this one is looking like that material. But take a look, this surface, some different color, which means this is not just simple color. This is high quality image-based texture map, okay? And also not that reflective, but slightly reflection it has, and some matte reflection, not that high glossy. All such numbers are predefined in that material. How about this one, glass thin geometry? So this one is not that looking solid or heavyweight. This one looking very lightweight, simply because this one is the glass object for very thin thickness surface, okay? Hollow inside glass object. This one, glossy plastic in this color. If you load this glossy plastic with this color, but if you want to change this color to blue, simply change the color blue, that's all, okay? Reflection rate or some bump map or other effects already preloaded, okay? Take a look this masonry. Masonry means bricks, okay? Accumulated bricks. So between two bricks, some parts extruded or not. Thanks to bump map and displacement map preloaded on top of this material, masonry, okay? So different type of masonry or different type of effect can be available. You can control some easy to use options in this material editor. This is one snapshot of today's lab exercise, okay? The same as the way to create basic environment, floor plane, okay? One single plane as a bottom floor and one object, in this case, teapot. But if you assign amount of Autodesk material or mental ray material, whatever, your own texture image, whatever, you can generate in the same view, same scene, but totally different material, okay? Take a look, this is water object. Of course, in reality, it's not possible. You cannot make this kind of teapot object using water, but anyway, it's possible only just for visualization. This is glass, but take a look. Environment color default is black. So there is no sky or background images, but for this kind of glass, you can assign some sky image as an environment so that you can reflect the sky in this object. But this one, totally black, simply because environment is black. if you change environment color to white, this one going to be very white, and your objects also getting brighter, simply because the environment is white colored, bright. So also mental ray, sun and sky, we installed last week mental ray, sun and sky. Okay, that is why this sky is looking like real clean sky in blue. This is 12 p.m. style. Okay, just installing mental ray, sun and sky, and render it based upon this geometry. This is one of the preview of today's lab exercise. But if you change the color, change the time to 5:30 a.m., you can even see this sun disk, okay? This is mental ray sun. And take a look, sky environmental color. It looks like kind of yellow, looking very early morning like sky view, and a little bit brighter, a little bit darker than 12 p.m. Because mental ray sun and sky, it has kind of default realistic environment for your visualization. So even for building interior, external sun system, mental ray sun and sky will change your interior scene's feeling, okay, environment. The same as exterior, general scene is looking like in these different ways. Okay, based upon this lecture, we're going to move on to today's series of lab exercises from now, okay?